this button here. We're going to stream to YouTube. There you go. We're live, I believe, on YouTube. I think. Okay, so astrosurface. I don't know this. We should. Oh, I know what I was going to say. So the reason I shouted out Misadventure Astro, I started working on the old Stream PC today to convert it to be used in the observatory. The PC that we have out there, I think, is just not quite up to the task. The PC out there is an old Linux box that I built, gosh, 10, 12 years ago. And it was great for running Linux, but then I installed Windows on it, which is just a bloated, horrible mess, and it's just too slow. So I'm going to put the old Stream PC out there once I get it all updated. And hopefully that will mean that we'll be able to see a little better on the screen. And it should be faster as well. It's got more RAM, it's got more hard disk space, it's got a faster hard drive. That all should help us with our planetary imaging. I'm going to go back, but I actually want to do this. I'm actually going to copy this into chat so that I can find it later. There we go. It's if you want to know what the dtext thing is, it puts it into a channel called Stream Links on the Discord. So after streams, you can go in that channel on the Discord and you can find any stories that we talked about, that kind of stuff. But yeah, beautiful, beautiful work, and it looks like he's got some other. Oh, look at this Saturn. Oh yeah, love it, love it. That Edge 14 is just a light bucket. Holy cow. We actually this is Venus, obviously. I mean, I shouldn't say obviously. This is Venus. Kind of interested in moon images. I'm interested in it all. Like I have never really been into planetary astronomy, but I've been chasing Jupiter, and my seeing has been so crummy. But the other night we managed to get Uranus as well, much to someone's delight, who kept using the word Uranus because they thought it was funny. But besides that, it was actually a really good idea. And yeah, we got some really good shots of Uranus. I mean, it wasn't, but you could see it was a disk. You could definitely see it was a planet. I was surprised. But I've really got into the planetary this year as well as the deep sky. I mean, we'll still be doing deep sky as well. Uranus sky, yes, Uranus sky. The funny thing was, I think every single mod in chat was messaging me like, "Can I? Can I? Can I?" And I was like, all right now, we'll let it ride." They were like walking they were walking the line so finely. I mean, it was well played. It was well played. Every time I was like, "Right, that's it," they sort of backed off a little bit. So, fair play, whatever. Let's have a look at yesterday's Apod. Ooh, it's a nice galaxy. The world is it M50? Yeah, M51. Yeah, M51. The Whirlpool Galaxy. Check it out. Check it out now. Wait. Why didn't the music play? Is the music too loud, or is it good for you guys? The Whirlpool Galaxy is a classic spiral galaxy at only 30 million light years distant and fully 60,000 light years across. Wow. Wait. So it. Oh, 60,000. I got you. Also known as NGC 5194, is one of the brightest and most picturesque galaxies in the sky. The featured deep image is a digital combination of images taken in different colors over 58 hours with a telescope from Lijiang, China. Anyone with a good pair of binoculars, however, can see this whirlpool toward the constellation of the hunting dogs Canis Venatici. M51 is a spiral galaxy of type SC. And if you remember the tuning fork diagram, galaxy tuning fork. The Hubble tuning fork, here we go. So here's SC is up here. So this is like a fairly open spiral. This is ellipticals, if you remember, and then this is like S0, then more arms and more open, go up this way, and then if you just have one pair of arms, working music volume is good. Excellent, excellent. Thank you, Petrodactylus. Hope you're doing well. Thank you for the lurk. I appreciate you. Yeah, so if you only have one pair of arms, like this, these galaxies here, you can see that they just kind of have a one. It's not really I guess it's a spiral. I don't know. Anyway, whatever. These are the SBs, a barred spiral, so it has a bar across the middle. And typically, the bar means that you don't get the same structure. And then here you can see that I think that actually is the prototypical SC. I think that's the whirlpool actually that they've used. So. Over how many days will those 58 hours be spread out? They won't be able to image it. Yeah, right. No, that's right, Beatrice TV. Yeah, so If you're doing it, it depends. So if you're waiting for like dark, like astronomical dark,
Leroy
you might get
Jenkins.
6 or 7 hours out of a night. Big Gamey's in his house. Big Gamey, welcome in. We were just talking about you a little bit earlier. Welcome, welcome. Um, uh, yeah. So maybe 10 nights or something. They probably wouldn't be consecutive nights. You know, you might have clouds. You might have your ears were burning. Well, we didn't mean to set fire to your ears. I apologize for that. I apologize for that. Um, yeah. So this is M51. I wonder if M51 is up. We could potentially go after M51 later, but I don't know. I'm trying to think when it might be. So stacks on stacks on stacks, multiple rooms at Sasquatch. Yeah. Well, what you do typically for an image like this, you might do so. So for example, for an image like this one, I don't know what the filters they used were, but you would typically for deep sky, you're using a set of narrowband, what are called narrowband filters. So you'll measure in luminance, red, green, and blue filters, and then you'll use sulfur, oxygen, and hydrogen, H alpha, S3 and O2 filters, and then you will combine the data. And usually what you'll do is shorter exposures. So you wouldn't just observe for like 7 hours in one filter and one exposure. You'll do maybe, it depends. You might do a minute, you might do 5 minutes if you're feeling lucky. One of the reasons you want to do that is because you can always throw, like, if something happens, I don't know, let's say you're in the middle of taking it and a neighbor turns a light on or something and ruins a frame, you can just throw it away. If you've been taking a frame for an hour and they do that, you've just lost an hour of data. Whereas if you're just doing 5 minute exposures, something happens, or maybe some cloud comes over. So typically you'll do shorter exposures. And then then you'll take dark frames. So you'll put the cap over the CCD or over the telescope, and then you'll take a picture with the CCD covered, so it's dark. So you pick up any current or any weirdness that's happening just in the CCD. And then you'll take a light frame as well, which is an evenly illuminated frame, and that will show up other things like if you have dust on the lens, that can show that up. And then you'll subtract those and you'll take a bunch of those and you'll average them.
A wizard is never late.
Misadventures in Astro. And then you'll subtract the dark
Nor is he
frames
early.
and the
He arrives precisely
and your
when
dark
he
frames
means
and your or your flat frames will be the same length as your light frames, and then you'll subtract all of those. There's some other things you can do as well. You'll subtract those, and then you'll stack everything together. And then there's software that would like register, the stars, and it will because there'll be some rotation in the image over the course of the night. It'll derotate it, and it will put it on make sure everything's lined up, and it'll stack all your data for you. And you'll do that in each channel. So you'll do red, green, and blue separately. And then you can combine those channels. Some people use Photoshop or whatever you want to use, and you'll color those channels according to whatever color scheme you choose. I guess. Does that make sense? Seribot. What happened to Seribot? What happened to Seribot? Yeah. So it's a really long process, and some people enjoy like the astronomy side of it, like taking the images and actually being out with the telescope and doing all that part of it. And then they don't really enjoy the image processing side of it so much. Some people love the image processing and couldn't care less about gathering the data. Um, and so there are definitely teams of people, like some of these big groups, where they'll do a target and they'll all take the data, and then one of them will be responsible for all the stacking and all the other stuff. So it just depends. But yeah, a lot of people like us, like the people in chat generally, we do everything. So we do everything from gathering the data um to doing the stacking and everything. And you know, it's this the I would say the image processing is almost harder than the data gathering. The data gathering is pretty mechanical, like, yeah, it has to be in focus and you need a well-balanced setup and, but pretty much it's kind of automated. It's actually processing the data. Big Gamey, thank you for the 100 biddies. I apologize that we are getting no sound effects, zero sound effects from our delightfully amazing software. I wonder. I'm still trying to figure out where the sound settings are for this, and why it won't play the sound where we want it to. So yeah. So that's the deal with imaging. Deep sky is more involved than planetary, I would say, probably. Planetary is a little easier because your targets are much brighter, but you're also dealing with a lot more with atmospheric effects from that, so the planetary can be a bit more frustrating. But you've seen like the stacking that we've done where it just keeps the best images and throws away the worst ones. So you can do some really cool stuff with the planetary as well. It's all just skills that you learn and that you have to, brush up and practice. And thank you for the 100 biddies, Big Gamey. Why did the tomato blush? Because it saw the salad dressing. Why did ducks make great detectives? They always quack the case. Hopefully Big Gamey did not see the LED message. Wait. There's an LED message? Pro NASA streamer. Wait, what am I not pro streaming now? What's happening? I don't know what's happening. Guys, play a drop game. If you drop for 99 or more, you know what happens. You get one of those free gifted subs. I'm going to drop with, let's see. This is the perfect emote. This is going to be a winning drop right here. Unless somebody wants to confuse the streamer. Yes, exactly. Unless someone wants to drop real quick and come down and bounce me off the wall or something. No? Okay. I do just want to hype up our solar stuff as well. So we do have a Ko-fi fundraiser going on to buy some optics that will let us look at the sun and do spectroscopy on the sun, which is going to be amazing. Yeah, I have a command. You would think I would have done that, but Mrs. Mentions Astro is on the case. So this will allow us to make images of the sun in a bunch of different wavelengths. It would be super cool, really cool. And we get nothing but sun here in California, so it would be a really cool daytime observing type of thing. I'm not sure how hot the setup would get, but you could potentially just leave it going all day, I don't know how hot things are going to get. So obviously when you're gathering sunlight through a lens, stuff does get warm, but okay, what was I going to do? Oh, I was looking up M51, right? I didn't really. Was it M51? Yeah, M51. It is M51. M51 is going to be up around 11. It's probably kind of late. Shuttle stories. Hey, thank you for the redeem, Wombat Hole. We can do some shuttle stories. Why has my music stopped again? Shuttle stories is right here. This is Shuttle Stories. It's a great book. It's from the Smithsonian. I want to say it was $35. It's $35. It's $35. Order it from the Smithsonian. Don't order it from, if you can get it directly, don't get it from Evil Corp. But this has every mission. This has every mission in it. And it's beautiful. Can we add the command to the stream title? Wait, can we add what command? What do you want? You can do whatever you want, Big Amy. You have fun. If you have permissions. If you don't, then just let me know what you're trying to do and I can do it for you. But yeah, it's got amazing pictures. Look at this. It's just full of amazing pictures, honestly. Just one after another. And a really cool description of each mission. They've actually got the mission specialists and astronauts and pilots and stuff that were on the missions describing it. And Astro Canuck, welcome in. Slightly late Dino Raider. Astro Canuck, you're never late. You're fashionably late, sir. Guys, make sure you're following Astro Canuck. Amazing streamer here on the platform. Was streaming with NASA, I think, today, right? Yes, today. The days are going. Astro Canuck's doing Legos. He's doing NASA Lego with NASA. What do you want, What do you want? What more do you want? Are you not entertained? Get over there. Follow Astrocanuck if you're not already. He's amazing. He's amazing. I'm sure you all already are. But yeah, also does astrophotography as well as Lego and eats hot food. Just has some excellent redeems on the stream. Highly recommended. Twitch ambassador in the making, for sure.
A wizard
For
is
sure.
never late.
You want sleep, Wombat Hole? No worries. We are going to do your redeem right now if you're thinking about leaving.
He arrives precisely when he means to.
There you go. It's probably copyrighted content. That's probably got me muted on on the other stream. All right. Hello, Autopilot 190. How you doing? Good to see you. Oh, did we do this one already? I had the bookmark in here, but I don't know if we did this. I think we did. I think we're on mission 41C. Mission 41C. This was Challenger. Okay, actually, you got me. Whoever did that, you got me. The dad joke. It's cycling dad jokes. Let's do the dad joke real quick, then we'll get back to mission 41C. Why can't an elephant ride a bicycle? Because he doesn't have a thumb to ring the bell. You have sugar and coffee? Aha. I almost had a cup of coffee this evening, which is highly unusual for me. All right, 41C. This was a Challenger mission. It was April the 6th, 1984 to April the 13th, 1984. 6 days, 23 hours, 40 minutes, and 7 seconds. Robert L. Crippen, Francis R. Dick Scobie, George D. Pinky Nelson, these names, man. James D. A. Ox Van Hoften, and Terry J. Hart. STS-41C deployed the bus-size LDEF satellite with 57 material science experiments, then rendezvoused with the Solar Max satellite. Spacewalkers Ox Van Hoften and Pinky Nelson repaired the satellite's electronics using MMUs. Astronauts then returned Solar Max to orbit. There you go.
Allegedly.
Allegedly, Scooby-Doo. Was it Dick? No, who was Scooby-Doo? No. Who was the guy in Scooby-Doo? I'm forgetting now. Okay. So this is as told hearsay. This is as told by James Van Hoften, mission specialist. We were the 11th shuttle flight. It was originally designated STS-13 back when they were still numbering flights. NASA, however, was upset by the number 13 and comparisons to Apollo 13, so the agency renamed all future flights, and so we became STS-41C. That designation meant that the flight launched in fiscal year 1984 from Launch Pad 1 at Kennedy Space Center, and the C meant that it was the third scheduled flight that year. Very confusing. Actually, it seems pretty... Okay. We had a great crew with Bob Crippen as an experienced commander and 4 astronauts from the large class of 35 selected in 1978 who became known as the 35 New Guys, TFNGs. On our mission, the TFNGs were Terry Hart on the RMS, then Pinky and me on EVA, and Dick Scobie as the rookie pilot. What was important about STS-41C was that this would be the first shuttle flight to demonstrate the value of humans in space and the unique utility of the shuttle. Besides launching the Long Duration Exposure Facility, LDEF satellite, we were scheduled to repair the Solar Max satellite, which had lost its primary gyro system and suffered a few other technical issues. Luckily, Solar Max was the first satellite designed with the idea of on-service orbit. The MMU, which I think is short for Manned Maneuvering Unit, so these were the backpacks that they used to maneuver around in space. The MMU was designed for just this type of work. It was propelled by compressed nitrogen and steered by 44 reaction control nozzles. To attach the MMU astronaut to the Solar Max, we were supposed to use a device called the T-Pad, the Trunnion Pin Attachment Device. It was designed to dock with a grapple fixture on the satellite, similar to the ones used for attachment by the RMS, the shuttle's Canadian-built robot arm. We trained over and over for this retrieval, but when we got in orbit and Pinky tried to dock with the Solar Max, the T-Pad wouldn't lock on the trunnion pin. He made several attempts, but only managed to bump the satellite into a tumble. Oh no. Can you imagine? Pinky did try to fly out to the satellite's solar array and manually stabilize the motion, but was unsuccessful. We later were told that there was a thermal blanket not mocked up in the simulator, which prevented the docking. We terminated the EVA on that first day and went back inside with our tails between our legs. From inside, we could see Solar Max slowly tumbling nearby. I mean, can you imagine? Like, oh my god. And we flew close by so that Terry Hart could use the shuttle arm to grapple and place the satellite on the orbiter platform. We would then go for EVA repairs the next day. We went out 2 days after the first try and were out for about 8 hours. We performed the repairs in about a quarter of the time we thought it would take. Of course, our training was planned around all the things that could go wrong, but the repair went without any issues. We got the gyros on it in nothing flat and then removed and replaced the computer board. Given the problems that we had, the fact that we were able to complete the repairs successfully made it just a spectacular flight. I recall having one selfish thought on the flight back after landing at Edwards. You can't take this experience away from me. That's pretty cool. So this is these are pictures. I guess this is the satellite after it's been. Oh, let me see if I can get rid of that glare. This is the satellite down at the bottom here after they got the robot arm on it, and then there's the astronaut here with the MMU on. That is, I think it's Hart. Let me see. Does it say? Oh no, this is Van Hoften. And you can see, actually, that's a really cool picture. In the background, you can actually see the satellite. This is where's I can't move my finger the right way. This is actually the satellite they were working on in the bay. How cool is that, guys? Thank you for that. Thank you for the Space Shuttle Stories Redeem. It's such a beautiful book, and it really is interesting. It's the best $35 you could spend, honestly. I reckon, in my opinion, just my opinion. Okay, we do have ads incoming. Let me check the ad schedule. I think we have a minute more than it says we do. It says we have 40 seconds. I think we have a minute and 40 seconds. So yeah, let me mark that redeem as done. We did the dad joke, terrible as it was. Alrighty, let me see. I think this should be the end of a pod. Oh, we didn't look and see what equipment was used for this image. Image. Let me just double check I didn't miss anything and. No bumping a satellite. I mean, can you imagine like going out there and just catching it with the thumb or something and just sending it into a tumble that is not. Shaggy. No, Shaggy was one of the guys. What was the guy? No. The other guy. The guy that was in charge. Not Shaggy. No. Not Shaggy. Fred. Yeah, Fred. Thank you. Misadventure Astro. Misadventure Astro's got it. Let's have a look on Instagram. Fred, exactly. Oh, wow. Good lord. Gum 23. This is Vila. Oh, I'm gonna we got 30 seconds. Hold on. Daphne, Wilma, Velma, Shaggy, and Fred, and Scooby. And Scrappy, potentially, if you're into this whole Scrappy thing. Facts and technical. This was taken with a Takahashi FSQ 106 EDP. Player 1 Poseidon M Pro from Namibia. 8 hours of integration time. What a spectacular image. All right, guys. We're going to take a quick break. We will be right back. We'll see you then. Guys, for those of you still here, thank you for the subs and the turbo. I'll be right back. 3 minutes. Play the maze game. You know the deal. 3i Atlas is a bit different since it originated in another part of our galaxy, perhaps around a distant star. It was discovered on July the 1st, and we have talked about that discovery in a previous video, but now we have exciting updates. Since the initial discovery, we've had a bunch of cool follow-up observations with huge telescopes. Most recently, the Hubble Space Telescope captured 4 images of the comet. The 4 images were taken in 2 pairs, about 90 minutes apart. On screen, you can see the change in position of the comet between the first pair of images, which were separated by about 2 minutes. The star trails in the image are because each exposure was 40 seconds long, and Hubble was tracking the comet, not the stars. We actually made this GIF live on my Twitch stream yesterday, and the amazing thing is that this Hubble data is freely available to everyone over on the Mars website. If you're feeling adventurous, you can grab actual data from the Hubble Space Telescope, play around with it, and look at these images for yourself, and confirm that yes, there really is a comet there. Any imaging processing software that can handle the FITS file format will work, including the open source GIMP and SAO image. We made this second GIF from the second pair of images. These were two 25-second exposures about 3 minutes apart, taken about 90 minutes after the first pair. So the background stars do look different. Before I talk about the other observations from the Vera C. Rubin telescope, I want to ask that if you enjoy this kind of content, please drop a like on it and consider subscribing to the channel to help promote our mission of science engagement and outreach. Okay, that's it. Back to Vera C. Rubin, which is still in its commissioning phase. Once the comet was discovered, astronomers started going back through the data to see if Rubin had observed the patch of sky where the comet is during its testing. In a preprint published on the archive server July 21st by Chandler et al., the team reported that they found the comet in 37 Rubin images going back as far as June 21st. On the screen is a stack of 21 30-second images of the comet as seen by Rubin. Having so many observations, the team were able to constrain the size of the comet to between 4.8 and 6.4 kilometers, refine the orbit of the comet, and also constrain its absolute magnitude, which is a scale astronomers use to define the intrinsic or true brightness of an astronomical object at a particular wavelength. It's really neat to see all these advanced telescopes looking at our newest interstellar visitor, and it's even more cool that a lot of this data is available to anyone, so you can check out and confirm these discoveries for yourself. I'll include a bunch of links in the description for everything I talked about here. That's today's video. I'll catch you in the next one. I got a couple really cool images for you today from ESA. One is an image of Earth taken from space, and the other is an image of space taken from Earth. This really striking image was taken by the Copernicus Sentinel-1 satellite and shows circular structures in the deserts of Saudi Arabia. Whilst you might guess that this is a military installation or perhaps oil storage tanks, this area is actually used to grow food. Each circle is about 1 kilometer in diameter and has a central pivot irrigation system at its center, which is a rotating sprinkler that irrigates the crops using water pulled from underground aquifers. The composite image is composed of 3 separate images captured by Sentinel-1 in October of 2024 and January and May of 2025, with these images colored blue, green, and red, respectively. By putting these images on top of each other, you can get a sense of how the land use has changed over the 9 or so months. Black circles indicate those areas not muted. Guys, I'm muted because I'm a pro streamer, and you guys always enjoy it more when you can't hear me, I believe, or something. Yes, pro streamer. Yes. What I was saying, I need to make that command, Casey Snowart, and it should just disconnect the stream. Like, that should just be the end of the stream. What I was saying was we should have a quick look and see if we can get Saturn before it sets. Saturn is still up, I believe, from my location. So let's have a quick look. I had the telescope out, as it were. It's already operational. I just slewed to somewhere in the vicinity of where I believe Saturn to be. Actually, you can see it on the screen already. Oh, that's handy. Look at us. It's like I even almost know what I'm doing. We're gonna go over here and we're gonna take a quick plate solve and see what's what. Just pray that we didn't run the telescope into the... it's not too bad. We're definitely not looking at Saturn, but I didn't run the telescope into the mount, which is always a plus. Let me catch up on chat, see if I missed anything here. Okay. It looks as though we're moving. Why is this? Why am I? Oh, I see. That's definitely Saturn. That is definitely Saturn. Okie dokie. And who doesn't love a good Saturn, you know? Hopefully we're safe tomorrow and keep power. Alien battle station is fully operational. Yes. Oh, whose Saturn is that? That's a cool Saturn. Oh, don't start, Misadventures. You're gonna get vicariously like banned by association. I think we should use. Well, here, let's do a little. We can do a little thingamy here with this telescope, but I think we should go. I think we should do. Oh my god, there it is. It's one of my favorites. It surely has to be one of everyone's favorites. Let's get some. Oh, the folk. No, I didn't. I was planning on doing this, but I did not do it. Whoa, 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 Saturn, chill, chill, buddy. I think what we're actually going to do is turn this off. We're going to zip over here, and we're going to have a sharp cap, and we're going to use the planetary camera on the. Hey, you guys. All right, let's see. Visionary. Nice. There's lots of Saturns, it seems. Oh shit! I have to go medicate the dog. I'll be right back, guys. Just give me 1 sec. Here, actually, let me get this set up. And no, I didn't. I'm not late. I'm not late. 7 p.m. I'm good. I'm good. Leave me alone. Oh wow, is this actually just working? Just like that? We're actually seeing the planet? Um, okay, well we're gonna do a live. I don't know about the focus though. I need the planetary live stack, and I need shorter exposure times here. Like 0.01 or something. Milliseconds, let's reset the stack. Um Zoom in. Not the greatest, is it? I'll be right back. I do have to go and oh, it's overexposed. Hold on. Go 50 milliseconds. Still, too many. 10. Now it's underexposed. Five? We had 50 and it didn't like 50. Now it's overexposed. I don't know what's going on. We're gonna try that. You'll just have to manage. I'll be right back, guys. All right, what do you think? Focus issues? Oh, wait, I'm trying to put these in the wrong ears. Another pro streamer move. All right, Darwin's had his medication. Let me just see if I don't know that anybody fed the pets. They might not have had their dinner. So now the cat has taken to coming over. The cat has taken to coming over when the dog is getting his medicine because he knows that there's going to be stuff left around. And Dr. Nerd we could use a little pill pocket, and we put it up on the counter, which she used to, and the cat would steal the pill pocket before she even realized what was going on. All right. I don't know what's going on with Saturn. I have a funny feeling our focus might be cruddy. I hate to try and do the focus thing again, but maybe we can. Maybe we can try. Tools. Focus assistant. Do automatic refocus, maybe? I don't feel like it's starting. Can I not start it when I'm doing... I probably should have paused the... I think I've just crashed it. I just crashed it. I'm an idiot. All right, well, we were trying to look at Saturn, guys. Okay, we legitimately thought that we were going to be seeing Saturn, so I don't take complete responsibility. Yeah, it's definitely dead. This is the problem. I think Magister was saying about this, that Sharpcaps. The thing is, we have to do Saturn now because it's going to be gone here in the not too distant future. So maybe this time, before I jump in and start doing the crazy cat, he's a little devil, man. He's like, there's no flies on that cat, I tell you. He's like, yep, I know when there's going to be food, and I am going to go help myself. We know. As you can see, the seeing is atrocious. Let's see if we can do the focus. Do you think it'll focus? Does anyone think it will focus on the planet very well? Has anyone hit the pile? Yeah, we've had a few landings in the pile. Quite a few landings in the pile. Select area. Okay, that's a good area. That's now out of focus completely. This may have been a bad idea. This may have been a bad idea. We'll see what happens. All right, guys, we're just trying to get Saturn in focus here, and then it's going to be amazing. Probably not, but we'll see. We'll see. It's low in the sky. For me now, currently, altitude of Saturn is... wait, I think I'm paused. Okay, altitude of Saturn is 33 degrees. So it's getting low in the sort of southwest sky. The tree, oh, by the way, the tree has had a major haircut. Might want to add averaging to the left side so that it averages more than one frame. Ooh, where do you see averaging? I see the window now. I bet I can't do it while it's going though, right? I'm probably just going to let it go for a minute. Let's let it run and see what it gets up to. We can do averaging in a minute. That's a good idea. It does look as though it's found some sort of minimum, maybe? Mm-mm-mm. The wind just blew the grill off the patio. Holy crap. That doesn't seem ideal. Is it that bad there? Focus scan stopped early. Best focus already found. Okay, this is supposed to be best focus now. Allegedly. Okay. That does look pretty good, actually. All right, we'll take that to be true. We're going to jump into the live stacker. We can probably do a different region of interest. Let's say track planet center. Then we probably don't need. Probably do 640 by 480. Planet in the middle there. Make this a little bit bigger. Apparently 47.9 milliseconds is too much. 45 milliseconds. How about that? The brightness is changing because it's A cold, windy fire watch going in tomorrow. Oh, man. Well, stay safe. Unpacking and setting up primary computer. Excellent. Excellent, Entropic. I'm excited to hear that. You have to give us full details. Take a pic. Let's see it. We could try the old histogram doodah here. Let's see. Where is the histogram thingy? Failed to receive data from socket. Just crashed my computer. I'm pretty sure it's just crashed my computer. It just... Okay, well, I didn't want to see Saturn anyway. That was just a little test thing there to see if anyone was paying attention. I do need to follow this person on Instagram. Let's follow. Nice. We actually just trashed the computer. Oh well. I think the mount, yeah, the mount looks as though it's still going. So hopefully the computer will reboot. We can reconnect. I am gonna, like I was saying earlier, I do have the old Stream PC here. It's got a good graphics card in it. It's got plenty of memory and all that stuff. So I was just fixing that up before stream. So that we can move it out there. It'll be much better. It's I mean, I was using it to stream and it was fine. So it's got a 2060 in it, which is kind of overkill, but I think it'll be much more stable and reliable than the PC that's out there. And it's just sat under the. I haven't really been doing anything with it. I haven't been using the dual stream setup. So, do you know this astrosurface software, Misadventures? Someone was using it to do their lunar surface picture for the astronomy picture of the day, actually. And it looked kind of cool. Wait, but that was your Instagram, but I didn't... Oh, yeah, here we go. Oh, I am following. Okay. All right, sorry. Let's go back. Sure you've heard of it? Yes, I imagine. I imagine so. All right, let's see. This is the solar eruption. Okay, we're good. We're done on that one. We're done on this one. We're done on this one. Launch schedule. Tomorrow. Long March 3, 8:47 a.m. This is all my time. If you go to Rocket Launch Live and put in your time, you will find that it gives you launches in your time. So there's 2 launches from China tomorrow, one at 8:47 a.m., one at 8:05 p.m. There is one in the evening, 8:18 p.m. from Vandenberg. I'll be interested to try and see that one, actually, because now with the tree very heavily trimmed, hopefully it's going to grow back from the ground. You know, it's going to become more bushy than tree. But we actually don't have the... I'll send you guys a picture, but we don't have the tree blocking our view now. So I'll be interested to see that. That's from Vandy tomorrow night, 8:18. And then the 17th, it says Spectrum from Norway, but I don't see a time or a date or anything. I'm not sure that that's going. And then on the Sunday, the 18th, at 2:04 p.m., there's a Falcon 9 from Cape Canaveral. And then another launch from China on Sunday as well at 11 p.m. But they don't usually... The only time they broadcast those live is usually when there's when they're manned. It looks the 22nd at 6:43 p.m. Tell me that's a stream day. Tell me it's a stream day. It's next Thursday. Yes. This is going to be perfect, guys. 6:43 p.m. That's like a sunset... Los Angeles, California. Okay, here we go. It is, let's go out a week. 22nd. Last light of 5:40, and an hour later we get that launch. It could be Jellyfish City. Could be Jellyfish City. We will definitely be streaming that one live. That'll be perfect. Right slap bang in the middle. Could not really be better. I mean, it could be at 6 p.m. But yeah, so that was something to look forward to. And then we're supposed to have Starship sometime in April, I think. Probably April 1st, I would imagine. Again, if you don't know Rocket Launch Live, it's a great place to go and get all of your launch needs fulfilled. Indeed, Leroy Jenkins. Okay, so we're going to talk about... Well, we can do Crew 11 first if you want, and then we're going to do Jupiter, and on the oxygen. The excess oxygen on Jupiter, I don't know about excess, more than we thought there was, anyway. So whoever was asking, this is the February the 6th is a big one. What's happening on February the 6th? Did I miss something? Oh, SLS. Yeah. Absolutely. And we'll be streaming that live. I don't know what day of the week that is. The 6th is a Friday. And that's what it's scheduled for. And we'll definitely be streaming that. Yep. For sure. Might see. Maybe we'll try and do a collab. Maybe I'm sure. Like probably Astro Canucks are going to be streaming it as well. So maybe we can collab with Astro Canucks or something and do a watch party co-stream or something. Some people are going to be there for the rollout. Nice. That would be really cool to see. Mine is currently on the floor because I've got nowhere else to put it. Mine's rolled out and on the pad, ready for launch. All right, so SpaceX Crew 11 astronauts. 4 astronauts are safely back on Earth after the first ever medical evacuation of the International Space Station. A SpaceX Crew Dragon capsule carrying NASA's Mike Finke and Zena Cardman, Japan's Kimiya Yui, and cosmonaut Oleg Platonov flies down in the Pacific Ocean off the coast of San Diego at 3:41 a.m. Eastern Time, which is 6:41 Pacific. No, sorry, 12:41 Pacific. 10.5 hours after undocking from the orbiting lab. Quartet was supposed to stay in space for another month or so, but came home early because one crew member experienced a medical issue. It was the first time in history, the ISS, that a mission had been shortened due to astronaut health reasons. Astronauts going to see the rollout. Nice. Finke, Cardman, Yui, and Platonov launched towards the ISS on August the 1st, kicking off SpaceX's Crew 11 mission on the orbiting lab for NASA. Ordinarily, such crew rotation flights last about 6 months, ending a few days after their successors arrive. Something out of the ordinary happened during Crew 11's home stretch. On the 7th, NASA announced it was cancelling a January 8th spacewalk by Cardman and Finke due to a medical concern with an ISS crew member. A day later, they said they were ending it. NASA has not identified the astronaut or given details about the health issue, citing privacy concerns. Agency has said the crew member is stable, stressing this is not a crisis. Not an emergency deorbit, even though we always retain that capability, and NASA and our partners train routinely. So yeah. So this is, it's not a, it was a not a life-threatening emergency, obviously. They can get them home. I don't know what the time is. Maybe someone in chat knows. I don't know how long they can technically, like how quickly they can get them back to the ground. I believe within 24 hours. Last night before stream, I clearly saw the Dragon capsule leading in front of the ISS around 5:30. Oh, nice. It was pretty cool. Oh, that's right. They're going home soon. Yeah. Totally going home soon. And now they are. Let me fire up the viewer and see if the PC rebooted. It did. It did reboot. Oh. Guys, let's see if we can bring up Saturn again real quick. Obviously, it's not very happy right now. It's not very happy, but let's jump in and see if we can sharp cap this puppy. We'll see if we can get a quick image of Saturn. Before we carry on. It's 10 hours. Yeah, it takes 10 hours, but I don't know how long the preparation takes, And then I guess they have to be at the right point in the orbit. I'm not sure how long that takes. You figure maybe another 10 hours. I imagine they could probably end up on the ground within 24 hours of deciding to leave. That would be my guess, but... Okay, so we're gonna... Let's see. There's Saturn. There she is. Cutie patootie. Hopefully focus does look better, actually. 5 seconds is obviously a bit extreme. Let's go 50 milliseconds. And let's center on the planet. Let's maybe select a smaller region of interest. And then let us go to the live stack. Oh, not the live stack. I meant the planetary live stack. Is it going to crash my computer again? New ASCOM release? Remind me later. A new ASCOM release. Okay, let's go to the planet live stacker. Is it really overexposed, though? It doesn't seem overexposed. All right, but there's Saturn, though. This is definitely Saturn, as you can see. I'm not really sure that our frame and filtering. The best. Let's do less. Let's do like 5% of the best. Reset the stack here. I don't think it's overexposed, to be honest, but maybe it is. It's the disc is the rings are edge on right now as well. That's what we're seeing there. So we're not going to get like a spectacular view of the rings, but you can definitely see, right? Definitely Saturn. Let's see if we can. Let's put the let's do some sharpening as well. Auto sharpen. I mean, you know, it's all right. Bear in mind that it is now low in the sky, low, low, low. It's like 20. Let me see. Well, 30 degrees. But it's sinking down into the crud of, you know, it's sinking down into the crud of the Simi Valley, above the Simi Valley. Yeah, you can definitely see the rings. Just imagine that we're looking edge on, right? So the rings do open up and close depending on the relative positions of the Earth and Saturn. Don't remember. Oh, let me see. Don't remember. 2032. We have to wait until 2032 to get the rings facing more towards us again. So, you know, it's a long. It's going to be a long 6 years. We're not completely. I think it was last year. Beginning of last year was the full Monty as far as edge on goes. But I don't really feel like we're getting much more detail here than we were before. I guess we could do this. I don't know that any of this is going to help. Brave Emily Tentacle, welcome in. Good to see you. How you doing? Guys, don't forget to play the drop game. If you drop for 99, you do get a free 1 month sub to the channel on Twitch. On Twitch, yeah, Twitch. Yeah. Let me actually make this bigger. That's about as big as I can make it for you guys because it's just going to start getting pixelated after that. How much gain have we got in this thing? 175. Oh, is that the right setting for this camera? Default gain player 1. Let's see. 210. Oh. 210. I mean, we can try that. That's gonna Jim, how you doing? Welcome in. I can't even hit the stack today. Oh, this could be good though. This could be really good. Ooh, just drifted through, but Jim hits the wait. Hold on. Sorry guys. Now it is overexposed. Yeah, because I increased the gain. Let's try maybe 40 or something. Reset that stack. Okay, it should start to appear there in a second. I'm not sure if it's going to be. I'm not sure it'll be much better than we were getting, but anyway, that's Saturn. I just wanted to have a go at it before we. So in the last week or two, we've seen Jupiter, Uranus, Saturn. Any other planets? Well, the moon, obviously. It's not technically a planet, but the moon, solar system object, and 3i Atlas. We saw 3i Atlas live on stream as well. That was pretty cool. In fact, Misadventure in Astro made a little video of our observations of 3i Atlas, which was really cool. I should have done a better job with darks and flats for those observations. I was lax, and we paid the price. But Venus, yep. We should be getting some Venus action. Mars, not so much. But yeah. Okay. Well, I'm gonna leave that. I'm gonna leave that stack, and we're getting 33 frames a second out of the camera. That's pretty good. Maybe we should do the filtering and just add like the best 1% of frames. Reset the stack. And I'm just gonna leave this. It didn't let me go to 1. I can't go to 1%. No, I can't. It won't let me go lower than 5% for some reason. Okay. All right. Well, whatever. I'm going to leave it running in the background. We'll come back and look later and see what we got. Demon Prince, welcome in. Good to see you. How you doing? Dinosaur. Okay, so to get back to our story of the Crew 11 astronauts, let me see if I can find the video. Crew 11 return video. Seems like a reasonable thing to search for. Videos. Here we go. This video contains content from ITV PLC who has blocked it on copyright grounds. Okay. Okay, so this is the NASA version. Oh, it's hauling ass, man. Holy cow. So this is what people could see from SoCal. I guess from other places on the planet as well, but Jupiter, yeah, for sure, IDK. We will definitely be looking at Jupiter later. I just wanted to get Saturn because it's starting to set, so I wanted to grab it early before it goes away. But yeah, we were looking at Saturn, Jupiter last stream. The seeing here in Southern California has been pretty terrible, but we did get some video we did get some frames of Jupiter. We got pretty nice look. But yeah, we'll definitely be pulling up Jupiter a little bit later as well. This was earlier today. How you doing, IDK? Good to see you. Yeah, Miss Adventures does some really cool astrophotography live on stream. I was watching him image Jupiter yesterday, and what else were we looking at? Miss Adventures. Yeah. I wonder how much of a kick you get when that drogue goes out. What did you do? You were just awesome. You were just awesome, Miss Adventures. That was all. Just look at the 150 millisecond. Got some nice photos of the moons. Yeah, you can see the moons really clearly. Where are you located, if you don't mind me asking, IDK? Where are you observing from? Miss Adventures in Astro, who's one of our chatters, is in Colorado, and he's had much better seeing than we've had here in SoCal for sure. There we go. Those are the full. Yeah. How did we get the recovery vessel and the spacecraft in the same shot when it's still 3.5 kilometers up in the air? I guess we're looking down, right? So that makes sense. Ninja Gloppy, welcome in. Good to see you. How you doing, guys? Make sure you're following Ninja Gloppy as well. Another astrophotographer here on the stream on the Twitch side. New Mexico. Ah, nice. I bet your seeing out there is pretty good, huh? Nice dark skies too. You had good seeing until the clouds rolled in, Ninja Gloppy. Yeah, I was seeing here. I haven't had good, like, you know, good seeing for the good seeing here has been in the mornings, like 11 a.m. is when the seeing's been good according to the charts. Really helpful. Oh, doing like 15 miles an hour. You watched it live? Nice. Nice, South Rebel. Yeah, it'd be super cool. There you go. 30, 300 meters. I mean, we know what's going to happen. I'm still like holding my breath. I'm still holding my breath. So they hit the water about 15 miles an hour, 18 miles an hour. It's got to be a pretty good jolt, I imagine. We go down. So yeah, that was re-entry and splashdown. Good to see that they're back on the slam into the water at 25 as a general landing. I mean, it's better than slamming into the water at like re-entry speed. It's down. Give me a break. Altitude 0.00. It's all over except the little ploosh. There you go. You can see the light from the thing reflect, or the heat reflecting on the water. There you go. All right. Happy now? Down? Definitely down? Okay. All right. Good. I'm glad you're happy. That we're gonna move. When I can, I'd like to get some more photos of Venus, but it's a little hard for me because it's super light out. Yeah, I think Venus is gonna be better here in a few weeks or months. All right, guys. So I wanted to talk about this. I made a video about this. Would you believe on the YouTube? I made a long form video on yesterday. Yeah, yesterday on the YouTubes. You can find it. Let's look. I talked about Jupiter. I did like a quick refresher on Jupiter and all the things we know about Jupiter. I even managed to slide a little bit of Kepler in there as well. We got Kepler's third law. So that was kind of fun. So if you do Kepler's third law says that the period squared is proportional to the orbital radius cubed. And if you have the period in years and the radius, the orbital radius, you don't have to worry about like the ellipticity. You can just kind of estimate it as a circle. And if you use that in astronomical units, then you can actually get rid of all the constants, and p squared is just equal to a cubed. So if you put in I forget what it is, 5.2, I think 5.2 astronomical units. So you end up with the period is equal to 5.2 to the 3/2, so cubed square rooted. And you get 11.8 years. It's pretty cool. It actually works. That Kepler was a smart dude, I tell you. Have to go, night, yeah, take it easy. Also look up and research my favorite thing about the universe, primordial black holes. Primordial black holes are super cool. But yeah, take it easy, IDK. No worries. Good to see you. Thanks for stopping by. So Yeah, so it's a 12-year, roughly 12-year orbit, but its day is only 10 hours. It is spinning, man, really quickly. So effectively you get two rotations of the Great Red Spot all the way around the planet in less than 24 hours, which is why Misadventures in Astro was able to capture that super cool video of the Great Red Spot orbiting moving around the planet. Absolutely amazing. I mean, in just an hour or two, it's moved quite a substantial distance, and that actually does cause Jupiter to be quite oblate, which means it's chunkier in the middle than it is on the poles. I forget how much. I think it's if you measure the diameter between, like on the equator, you get 10,000 kilometers more than if you measure it between the poles. I think that's how that works. Pretty smart for someone who didn't. Oh, there's lots of smart people that don't work at NASA, man. No question about that. Lots of smart people. Uh, but yeah, so it's oblate, more oblate than the Earth. Although I don't know if it's more percentage. I think it's like 6%, but I don't know if that's it. I can tell when you crop to do a square crop on the planet. Wait, what? You can. I'm not sure what you mean, Miss Adventures. Sorry, I'm misunderstanding something. Uh, this is what we got so far on Saturn. It's not super impressive. I'm not gonna lie. But there you go. That's Saturn. That little blob there. You can see the rings. I mean, just about. You can imagine the rings might be there, maybe. We could really kick the butt out of the sharpening. I don't really like to do that, though. What stabilization do we have on? Yeah. I don't know. It is what it is. Easily measurable. Oh, yeah, yeah. I understand. Sorry. Yeah. Yeah. Yes, I know exactly what you mean. I got you. Yeah, if you crop it to a square, it doesn't fit, right? It doesn't fit. Um, it's been visited by 9 spacecraft, of which Juno is still there. Galileo dropped a probe. I don't know if you remember this. Galileo, some of you wouldn't remember because you weren't alive, but Galileo dropped a probe into the surface of Jupiter, or the cloud tops, basically, and it got destroyed. It made it 150 kilometers into the atmosphere, which is a decent depth, but not anywhere near getting down to the surface, kind of thing. And it got destroyed. And then they dumped Galileo in as well. I think was it Galileo that observed Shoemaker-Levy hitting. Here, let's have a quick look. Galileo probe. Yeah, so this was Galileo. It's kind of a cool. This artist concept stuff is so cool. Yeah. So let me see. It was built at JPL. Yeah, true. What was the mission date? Was 1989 until 2003. Yeah, I think it dropped the probe in like 94, maybe. Let's see. Where's the actual mission stuff? Hold on here. This is the probe that it dropped. The probe's electronics were powered by 13 lithium sulfur dioxide batteries manufactured by Honeywell. It doesn't really have the. Might be wrong about the observing the comet hitting the. Does it have like a. I believe they destroyed it. You can't see the scene. Oh, for fuck's sake! Pro streamer, guys. Pro streamer, okay? Pro streamer. You know that. You know that. You're not missing anything. I'm just looking at Wikipedia. I'm just looking at Wikipedia. Oh, Charlie's Dragon 97.74. There's a good landing. Usually, when someone lands for that kind of a score, someone wins the drop game shortly afterwards. So give it a go. Yeah, I was just reading the Wikipedia page. But it was actually, I think they were worried about polluting. Was it Ganymede? They were worried about polluting or contaminating Ganymede. So that's why they that's why they dumped it into Jupiter's atmosphere to get rid of it and make sure that there's no way that it could accidentally put biological life on Ganymede that we later find and are like confused, you know. So that was cool. Anyway, now Juno is there. I think this is a Juno image if I had to guess. I'm pretty sure, not 1,000%, but I'm pretty sure. Oh, come on. Anyway, most of the information that we have about Jupiter's atmosphere below the surface, it comes from chemical models that we have of Jupiter. So we use chemistry to figure out what might be going on. You know, Lone Vaquero, thank you for that gifted sub. Let's see who got it. Who got the gifted sub? Ungoy. Ungoy1 got the gifted sub. Ungoy, enjoy the gifted. Thank you, Lone Vaquero. I appreciate you. Very kind. Yeah, so most of what we know about the lower atmosphere is just models. We know about the chemistry in the clouds. We know what are present in the clouds, and we then can we have models of the atmosphere, the pressure, what we think the pressure profile looks like, and the temperature profile looks like, and that's kind of how we've done it so far. What's cool about this paper is that they've combined combined hydrodynamics with chemistry in the model. So the model actually models the clouds and the water droplets in the clouds, or the cloud droplets. I guess they're not necessarily water, but you know what I mean. And yeah, that's the exciting thing about this. That's the exciting thing about this paper, and we'll talk about it here in a bit more detail. We'll just read this, I guess. This is a press release essentially by the metallic hydrogen. Yes, delicious. Delicious. This is a press release by the University of Chicago, which was one of the institutions. Spectacular clouds swirl across the surface of Jupiter. These clouds contain water just like Earth's, but are much denser on the gas giant, so thick that no spacecraft has been able to measure exactly what lies beneath. But a new study led by University of Chicago and Jet Propulsion Lab scientists has given us a deeper look at the planet by creating the most complete model to date of Jupiter's atmosphere. Among other things, the analysis addresses a long-standing question about how much oxygen the gas giant contains. It estimates that Jupiter has about 1.5 times more oxygen than the Sun. This helps scientists narrow down the picture of how all the planets in the solar system formed. So yeah, it used to be, I believe the sort of consensus number before was about a third. We thought that Jupiter contained a third of the oxygen of the Sun. So this is a factor of 5 more than that. And the reason it's interesting is because if you know how much oxygen there is in a planet's atmosphere, that tells you a lot about where it formed, because the most likely place for it to have got oxygen is water, right? And specifically, if it has a lot, probably it was accumulating frozen water, right? Because frozen water allows a planet to accumulate much more oxygen than water vapor. Water vapor is going to be hard for the planet to accumulate when it's forming. And so if you find a really large amount of oxygen in the atmosphere, that suggests that it was formed further away from the sun, because you need to be far enough out in the solar system that the water is frozen ice, right? So it's super interesting. Well, it's super interesting for just Jupiter in general, right? It's really cool to understand more about the atmosphere of Jupiter, but it's also really cool for models of solar system formation and all that stuff. And particularly in the context of finding so many Jupiter-like planets in exoplanet systems, in exosolar systems. It's really interesting. So that's kind of why people are interested in this stuff. I got a concrete shipping date now. Up until yesterday, it was only estimated to arrive Friday, but I got an estimate bumping up the date to next Monday. Oh, nice. That's for the Dob. Very nice. I may unfollow now. I can't believe you would say that. So it goes with evidence of gas. Yeah, exactly, misadventures. Yeah. So it does look as though it has migrated inwards. Jupiter aliens capturing more comets than the Sun aliens. It could be. It could be, Captain Failure. That's possible. Or their dreadnought was made of ice, perhaps, and melted when it got too close to the Sun, like in an Icarus, like, I don't really know. The physical properties of water. Yes, hooray for water. Exactly. Okay, so there is a long-standing debate in planetary studies. And when someone says long-standing debate, that means like raging argument. Said Ji-Hun Yang, a postdoctoral researcher at U Chicago and first author on the paper. University of Chicago has a really good astrophysics department, by the way. It's a testament to how the latest generation of computational models can transform our understanding of other planets. So it should be said, it's worth noting that this is just a computer model, right? So we don't know for sure that this is the dealio, but the model is correct. The model gives the correct results at the surface, right? It can produce the clouds that we see at the surface. And then, we have some data, right? We have data up to 150 kilometers down, so you can try and match that. And then what happens below that is a bit of a, I don't want to say guess, but guess. This is cool. This is actually very similar to what Misadventures in Astro did. And this is Hubble Space Telescope data, by the way. This is Hubble Space Telescope data, so this is pretty darn cool that Misadventures managed to get something similar to this. Yeah, I'll show you. Well, I think we talked about this before, but let's do it again because it's so cool. If you go to the photo section, where is it? Yeah. Oh, did you put it in? Yes, here we go. So that's Hubble Space Telescope, and this is Misadventures in Astro Telescope, the MAT telescope. Oh, come on. Why do you make it so small? So his does bounce back and forth, not because he has control over Jupiter, but I think it's just looping. Very cool. Very cool. I mean, you tell me. Like, that's Misadventures in Astro. This is Hubble Space Telescope. Okay, it's a little better. How much more did it cost, though? I know. Corporate wants you to find the difference between these two images. They are exactly the same. Guys, make sure you're following Finite Singularity as well. Awesome streamer. He actually has a PhD in civil engineering, believe it or not. He researched earthquake stability, building stability in earthquakes. Very cool stuff. Now does OBS plugin development live on stream. You can watch him coding. And highly recommend it. We did a collab with Finite back in December for our holiday science collab. So freaking lethal, welcome in. Good to see you. How you doing? Can we send you a 9.25 in orbit? I mean, potential. We could try. Mini Hubble, yeah. Mini Hubble. I mean, what would it take? Quite a bit, probably. I don't think that would be easy. It'd probably be cheaper to just take it to Chile and stick it on top of, one of the mountains there at one of those farms for $1,000 a month. Honestly. And we probably wouldn't get much worse result. Where's the fun? I know. I'm just trying to imagine how big of a... I mean, I guess maybe if you did like if you had like a carbon frame to hold the secondary. But how many U does the CubeSat need to be? I guess is the question that we need an answer to. Okay, we've known about Jupiter's stormy skies for at least 360 years. 360 years people have been looking at Jupiter. That's when astronomers using early telescopes documented a curious, large, permanent blotch on Jupiter's surface. The Great Red Spot is a gigantic storm, twice the size of Earth, that has swelled for centuries. It's just one of many on the planet, as fierce winds and deep clouds mean the entirety of Jupiter's surface is covered in a kaleidoscope, no less, of storms. So the deal with this is all these bands that you can see are just cloud bands, and then you can almost see the turbulence, but between the bands, these winds are whipping in different directions, and there's a massive amount of turbulence at the boundaries of all these things. It's a really interesting environment. Okay, it says, what we don't know is precisely what lies beneath these storms. The clouds are so thick that NASA's Galileo spacecraft lost contact with Earth as it plunged into the deeper atmosphere in 2003. The next mission to visit Jupiter, Juno, is currently cataloging the planet from a safe distance in orbit. Mercury and Venus are missing from my Twitch emote memories. Uh-oh. Oh, well. Hold on. My headphones just fell down. Spare headphones. Whatever. Super cool. These measurements from orbit can tell us the components in the upper atmosphere: ammonia, methane, ammonium hydrosulfide, water, and carbon monoxide, amongst others. Metallic hydrogen, if you like. Scientists have combined this with knowledge about chemical reactions to build models of Jupiter's deep atmosphere. But studies have disagreed about certain points, minor points, such as how much water and thus oxygen the planet contains. Yang saw an opportunity to apply a new generation of chemical modeling to the knotty question. Chemistry of Jupiter's upper atmosphere. Oh my God, hold on one sec, guys. Sorry for the interruption. The chemistry of Jupiter's atmosphere is incredibly complex. Molecules travel between the extremely hot conditions deep in the atmosphere and the cooler upper regions, changing phases and rearranging into different molecules via thousands of different types of reactions. But the behavior of clouds and droplets has to be accounted for too. So the other thing that they found in this study is that Jupiter's atmosphere is cycling about 35 to 40 times slower than previously believed. So, like the upwelling from molecules being down close to the surface to being brought up to the tops of the clouds is happening much more slowly than previously believed, according to this model. Again, okay. These jokes in this book, I just want to say that this is cycling dad jokes, and some of these are not barely even jokes. Guys, don't forget to check out the collab on Sunday night. I'm going to be having two amazing guests on stream. I'm having Mackie Narrow, who is an illustrator and scientific comic creator, and Amber Dance, who is a scientist, a science writer, journalist, and teacher. So come and learn about all the different ways that you can communicate science. That's what we'll be talking about. That is what we'll be talking about. Okay. How many cyclists does it take to screw in a light bulb? Just one, but the world revolves around him. These are terrible. I'm thinking about, yeah, they're not even dad jokes. They're just awful. What was the single learned item from your profession that shocked you the most? Probably some of the stuff in quantum mechanics, which is just weird. Really weird. What does it mean, or what does it imply? Wait. You mean the upwelling, the rotation of the atmosphere? I mean, it just has implications for like heat transport, right? How fast, because as those hot gases come up from lower down into the upper atmosphere, obviously they carry heat with them, right? And there's a cycle. So the speed that happens at may imply things about the. Didn't even get the joke. Nobody got. I don't think it was actually technically a joke. It was in a book of jokes, but I don't think that necessarily makes it a joke. In fact, here we'll just do a proper dad joke. What's the difference between a guitar and a fish? You can tune a guitar, but you can't tune a fish. I mean, that's quality right there. That is a quality joke. Okay, guys, we have ads incoming in about 30 seconds. We'll take a quick break. I'm gonna go stretch my legs. We'll be back. We don't do anything for the 3 minutes of the ads. We run 3 minutes of ads once an hour, then we're ad free and pre-roll free for an entire hour. So do stick around. We shall be back. Play the maze game, ! Wonder if you want to. I believe you can pick a character as well. I'm not clear on the details of that. But yeah, enjoy it. Why do scuba divers fall backwards into the water? Because if they fell forwards, they'd still be in the boat. I mean, that's quality right there. All right, guys, I'll be back in 3 minutes.
Varies from roughly 45 times the average Earth-Sun distance out to 1,600 times that distance. The researchers believe the diameter of the roughly spherical object is 700 kilometers, but that will need to be confirmed by follow-up radio telescope observations. If it is confirmed, then 2017 OF201 will be just the sixth dwarf planet that we know of. In 2006, the IAU updated the definition of a planet to have 3 criteria. First, it must orbit the sun directly, and second, it must be large enough to have a spherical shape. The third criteria is that it must clear its neighborhood, meaning that other than its moons, it can't share its orbit around the sun with any other object of comparable size. This is how Pluto lost its planethood and became a dwarf planet. Dwarf planets being objects that satisfy the first 2 criteria of being a planet but fail the third. The 5 currently known dwarf planets are Pluto, Ceres, Eris, Haumea, and Makemake. The discovery was made by looking at data from the Victor M. Blanco telescope and the Canada-France-Hawaii telescope. 2017 OF201 was found in 19 different images over 7 years. The researchers point out that all of the data they used to make this discovery was available in public archives, meaning that students, researchers, and citizen scientists could make similar discoveries. These discoveries have the potential to change our understanding of the outer solar system. That's your space update for today. Have a great weekend. I will see you back here on Monday. Jupiter used to be twice as large as it is today and had a magnetic field 50 times stronger. That's the conclusion of a new paper published in the journal Nature Astronomy. Often when scientists are trying to figure out the history of large gas giant planets like Jupiter, they consider factors like how fast gas could have accreted onto the planet over time. This new research, though, focuses on two of Jupiter's lesser-known moons that orbit very close to the planet inside the orbit of Jupiter's innermost Galilean moon, Io. Unlike most of the other Jovian moons, Amalthea and Phoebe have slight tilts to their orbits relative to Jupiter's equatorial plane. The astronomers were able to use these small inclinations, combined with the history of how Io's distance from Jupiter has changed over time, to calculate that around 3.8 million years after the first solids formed in the solar system, Jupiter was 2 to 2.5 times its current radius and had a magnetic field of around 21 millitesla, which is about 50 times its magnetic field today. Scientists are so interested in Jupiter because it's so massive and would have had a major impact on the formation and evolution of the solar system. This new paper gives us a great starting point to evolve our solar system models and figure out which ones end up creating a solar system like the one we live in today. That's your space update for today. I will see you back here tomorrow. Clean rooms are pretty common at scientific facilities and also at NASA labs where spacecraft are being assembled. The goal of a clean room, at least in a space context, is to provide a tightly controlled environment that minimizes airborne contamination of various sorts from dust to tiny organisms. That second one is especially important for NASA missions to other planets where we don't want to contaminate the planet with any kind of life from Earth. Obviously, when you're building a spacecraft, people are coming and going, and so some level of biological contamination is pretty much unavoidable. But scientists at NASA's Jet Propulsion Lab, working with others in India and Saudi Arabia, have discovered 26 previously unknown bacterial species in the...
All right, guys, we're back. Oh, we're back. Hey, okay. The girls are home, if you couldn't tell. A dad joke. Sofa King Lethal, what's blue and doesn't weigh much? Light blue. You're welcome. Minnie and I just got back from karate. Hold on one sec. All right, it was Minnie Nerd's first time back at it was Minnie. Wait, what is what? I The Sharks have no chance. Yeah, so she used to do karate before her surgery, and then she kind of got out of the habit. And tonight was her first night back. She decided that she was ready to go back, and yeah, I guess she had a really good time. It sounds like she did really well. Excuse me. She remembered everything. She remembered all the katas and all that stuff. So yeah, cool. You did karate? Yeah, she really enjoys it. She was a green belt. She's a green belt, so she had gone quite far. before. I mean, she did it for like 2 years, I think. I want to say maybe even almost 3 years. And then yeah, she's had the last year she hasn't done it, but now she's really excited to get back to it. So I'm sure she'll be. I think I can't remember green. I think they have 3 Dans in the like. I can't remember how many stripes there are, but we call them Dans in judo. I think they call them something else in karate. But yeah, she's super excited, so that's good. Uh, that's cool though, Ninja Gloppy. Did you enjoy it? Did you? Why? What made you give it up? Was it just too much, or? So Sofa King, did you get my? Did you get the? Did you get the reference? Did you get the joke? Design by Dave is rating 6 viewers. Guys, make sure you're following Design by Dave. What an amazing raid. Thank you so much. Good to see you. Dan Astro, thank you for the follow. Raiders, how was your stream? How was your stream? Astronomy show. Astronomy show. Good to see you. How you doing, buddy? Nice to see you. Design by Dave, thank you for the raid. Thanks for bringing the community over. I appreciate you. How was your stream? What were you up to? What were you talking about? Were you doing some photography? We have been, we went after Saturn briefly. Tried to get a little bit of Saturn. You used to do martial arts until COVID. Yeah, it was tough. Minnie Nerd was lucky. It was after COVID when she was old enough and started to take an interest. So you got a dad roast. We're a bit gamey since he said you're cursed. It's funny. Um, First light on the new DBS 114 F2 astrograph. Ooh, very nice. And how was it? Anything to share? Anything to share? Raiders, if you don't know me, I'm Nerdwino. I'm an astronomer with a PhD in astronomy from the University of Illinois. I worked at NASA for about 10 years, and now I stream on Twitch Tuesdays, Thursdays, and Sundays, and make YouTube content. We talk about the latest research and papers. Right now, we're talking about a paper showing 5 times more oxygen on Jupiter than we previously had thought there would be, which is kind of interesting for various reasons that we were talking about as well. We have an observatory in the backyard, which we fire up when the weather's clear. The weather's been atrocious here for the last little while, but finally this last week or two we've had some good weather. So right now we're sort of pointing somewhere towards Jupiter. I need to do a plate solve and get the pointing right, but those are the telescopes. We have an Celestron Edge HD8 on the right, and on the left is a Explore Scientific ED102. They're sort of basic triplet, 102 millimeter, 4-inch triplet. So, few kinks to work out and configurations set up, but promising. Nice. Were you using the mini cam? Yeah, and it's just a roll off. It's just like a little 6x8 roll off shed out there. Los Mandy. Yeah, I have the Los Mandy G11 Dan Astro. I actually went down to Los Mandy and picked it up. So they're only about 6 or 7, 8 miles from where I live. So yeah, I got the Los Mandy G11. Good eye. Good eye. Yep. Yeah, you can see it. Let me see. Let me bring the picture back. Yeah, there you go. Yeah, it's the G. It's black. It's the black one. It looks weird in this camera. I guess is using like the infrared or whatever. But yeah, it's a black G11. Then I have the extra plate under the edge for the fine tuning, the pointing between the two scopes. I'm gonna say G11, but the dual scope adapter on the top made it look a bit different. Yeah, this adapter in particular underneath the edge has an extra plate that allows you to adjust the pointing, the altitude and the azimuth basically. In addition, so that I can align the two telescopes because they weren't perfectly aligned. They were pretty well aligned, but with a small field of view, it wouldn't center the object on both. Whereas with that now, like I can put Jupiter in the middle of both chips, which is great. So yeah, it looks a little different. It's a bit more bulky. Usually, both sides would just look like this thing on the left. It would just be like two plates like that. So yeah, that's what it is. And then but yeah, so welcome in, Raiders. We also do some space-based Lego and a bunch of other stuff, but I hope you guys had a nice time with Design by Dave. Awesome streamer here on the platform. We're thinking we might go to the LA Astronomy Club Star Party up at Griffith Observatory on the 24th of January. We'll have to see. That would definitely be a live stream for sure. I have never tried to live stream from up there, but I think it would be okay. They do have Wi-Fi, and I think the 5G signal will be pretty good up there. So let's open up Nina and let's maybe grab a Let's grab a plate solve, get pointed up, and see what Jupiter looks like. It's probably going to look pretty bad. Design by Dave, if there's anything else you want to share, YouTube channel or all that stuff, feel free. Drop a link. If you need to go take care of yourself, do some post-stream stuff, I totally get it. Totally get it. Design by Dave actually shared a really cool image last stream, which I'm actually going to pop up right now. Hold on, because it was so cool. We were looking at Thor's helmet the other night, as it were. And Design by Dave shared this image that he captured. Hold on, I know you can't see it. I'm working on it. Give me a second. Here we go. Let it cook. All right, there you go. This is Thor's helmet with Design by Dave's self-designed or self-built telescope, designed and built telescope, and the Minicam 8. Beautiful work. 19 hours. 19 hours of data. Looks incredible. All right, let me go back to my Nina window, and yeah, that'll do. We'll load this up. We'll get some plate solving done. How long are you streaming for? I'll be on for another hour-ish, probably, Lodok. Maybe another 2 hours, somewhere in there. I usually stream 3 or 4 hours. My back can't really take too much more than that. I have a herniated disc in my back that just makes it uncomfortable to sit for more than 3 hours, really. But I can do 4. Occasionally, I'll do a longer stream, but can hear the Valkyries, right? It's so good. It's so good. Yeah, it's such a great image. Hold on, let me click the button here. Yes, connect all devices. Let me click that button and let me go back here. And yeah, it's so good. We actually managed to see a good bit the other day on stream. We managed to get some. We think we were observing in H alpha. I'm having some filter issues. I don't think my filters. I think the filters were not in the right order when they were sent to me. I didn't do any more misadventures. I decided what I needed to do was here. Let's do a plate solve and see how close we are to Jupiter. I decided what I needed to do was take my filter wheel off and try and figure out which filter is which. Because, but the trouble is, the ZWO filters that I have are mounted, but it doesn't say on them what they are. So if anybody has any tricks for figuring out between, I mean, the red, green, and blue, I got it. The LR, the G, and the B are good. The S, the H, and the O, if anybody has tricks. Like last night, I think we pretty much decided that the last filter, the 7th filter is probably sulfur, because we got nothing. Ooh, there we go. Oh, there you go. There's some Jovian moons for you. All 4 of them. Look at that. So pretty. Need to check it during daylight. Yes. Well, you're going to tell me to point it at the sun next or something, I suppose. Stare at the sun. You would think point... let's do a... let's do a bit less. I don't know what that does. I don't know if 0.01... Anyway, there's Jupiter. There's Jupiter for certain. We're gonna zoom in. We're gonna go over to the other cam here in a sec. I'm trying to get a bit of a better view. It'll be better on the other camera because we can stack it. Focus actually looks semi-decent there. Okay, I'm gonna bring up. Here's our window. So here's no, stop. Here's Jupiter with its 4 moons. Pretty cool. I'm going to guess Io, Europa, Ganymede, and Callisto in that order. Pretty easy to tell today. The other day it wasn't so easy to tell. Can you throw a prism on the other side of the yard, light up a ruler for the graduated marks, and test the filters to see what you get? Possibly, Bill Nash. That's actually not... yeah, that's not a bad idea. How you doing, by the way, Bill Nash? Good to see you guys. Make sure you're following Bill Nash as well. Yeah, you can see the seeing is not great. We've got like... I'm pretty sure this is in focus, but this is just seeing related. And I don't want to get this so that we can actually see Jupiter a little better. But if I get it so that we can see Jupiter, we're not going to be able to see the moons as easily. Oh, this is getting close now. We're close. I really want to get the planetary camera on it here in a second. Oh my God, how low can you go here? Oh, I'm an idiot. All right, I'm not seeing any. I'm not seeing. Oh, maybe I did see some bands there. Maybe I did see some bands. Hold on. All right. What we're gonna do is we're gonna kill Nina. We're gonna go over to. I don't know how we got distracted by this. We're talking about Jupiter. That's right. Other thing would be a test object, strong in H alpha rotation. Yeah, doing all right. Finished the first draft of my sci-fi novel. Ooh, nice. Working on a couple of side projects still, trying to get my plate clear. That sounds awesome. When are we expecting to be able to read the book, Bill Nash? Don't know what my minimum focus is. Looking at ZW's filter there, yes, yeah. They do all look very similar. There's not much in it. I mean, I'll get them out. I need to get them out and look at them, as you said, in the daylight. I'll probably do it tomorrow. We'll pull it off and we'll see what the deal is. It shouldn't be, I don't know. Maybe there's some information online. Maybe I'm missing some marks on the side as well. I might be missing some marks on the side that tell you what the filter is. I'll have to get a magnifying glass out and double check. They are mounted, so there's no reason why they couldn't have put some clue on the side. It's going to be a minute. I've got a chunk of rewriting soon, and I'm waiting for alpha readers to tell me how much it sucks. Oh, no. I'm sure it's awesome. I'm sure it doesn't suck. Okay, here we go. We're going to try again with this. Well, I think we should be in pretty good focus. Saturn looks okay, so we don't need to connect to the mount. And then I'm not quite sure why we're not seeing anything actually. Hold on, let's go. Let's go to the full Wait, what's going on here? Why am I not seeing a second is not showing up?
A wizard is never late.
I feel like
Frodo Baggins.
something weird is going on here.
Nor is
That's
he
what she
early.
said.
He arrives precisely when he means to.
Germ, welcome in. Good to see you. I'm a bit confused. Now I have to start Nina again and see where this is. I thought it was right in the middle. It was right in the middle of the field of view, no? What am I? Oh, there it is. Now suddenly it just appeared. When I started Nina, I fired up Nina and then all of a sudden we get Jupiter. God. I swear. I'm looking forward to upgrading this computer.
Well,
all right, there we go.
You know, that's just like
So we're probably looking at like
your opinion,
100
man.
I think 50 milliseconds roughly. There we go. Let's just go over to the stack here. It should say, okay, I'm gonna look. We're gonna draw a circle around Jupiter, a square. We're not gonna draw a circle. We're gonna draw this squarey circle here, and we're gonna use that. We're gonna reset this.
Allegedly.
You can actually see a couple of the moons here. What is going on though? Still overexposed. Okay, 15 milliseconds maybe. Now it's underexposed. Of course it is. Of course it is. Okay, let's reset the stack here and let's zoom in. Oh yeah. There's Jupiter. Looking pretty good. Looking pretty good, I'd say. Well, let's make this bigger for you guys. Make it as big as we can, as it were. A squarey circle. Yes, so Yogi one. It is a scientific. Yes, it is a scientific thing that is difficult for people. Is difficult for people to understand. Why is it not stacking any frames? Are they just? Is the quality that bad? Have I messed something up? I have 2 sharp caps running. That doesn't seem, that seems suboptimal to me. That seems very suboptimal. It looks the best we've seen. I'd say it looks the best we've seen. I think so. We could do some color manipulations. We can do auto adjust brightness. It does look pretty good. It's definitely not stacking many frames though. You know what we should do is probably do an ROI. We could probably do like an 800 by 600 region of interest and set it on the planet. Which doesn't appear to be here. Oh, there it is. So if I move this down, all right, that should get us a better frame rate. I think we could even go 640 by 480. All right, there we go. There, now we're getting like 70 frames a second. That seems better. And now we're overexposed. It's allegedly overexposed. 13 milliseconds. And then let's put this here. And let's reset the stack and let's go again. Here we go. All right, yeah, it is. I'd say the seeing is as good as it's been. Compared to what you get the other streams, this looks way better and you're watching in 480. Yeah. Yeah, for sure. Me likey. I think it looks good. Not letting me zoom in for some reason. Of course, the red spot I think is around the back right now. It's all spot in the back. Did I get so many? Yeah, she saw it the other day. She loved it. She thought it was super cool. It's definitely better with the. I think the focus is really good tonight as well. I'm pretty sure the focus is spot on, which helps a lot. Was there anything else that we did before that was kind of useful? It's just kind of small for you guys. Huh? Getting pixelated there. Color alignment. Where was that? Stabilization alignment. Realign color channels. Okay. Planet, full disk, or surface. I don't know that it makes a big difference. It's also going to reset the stack if I do that, which is. I wonder if that affects when you do this. Okay. I don't know. What do you think, guys? I'd say that's the best we've seen, and that is definitely Jupiter. I'm gonna actually. Even the unprocessed frames look better, right? Even if we show the unprocessed frames, like this looks way better than what we were getting the other night. The other night it looked like a friggin' fireball. And tonight it's like, yeah, okay, you know. It's definitely some seeing issues, but it's also still relatively low in the sky. And then that's what happens if you sharpen her up. Second that. Nice. BitGamey has seconded. So therefore, it is true. I kind of feel like if I make this window bigger, you guys would be able to see better, but I guess there's a limit to how big I can make the image before it gets pixelated. I don't know how many pixels this is across, actually. Is there a way to measure how many pixels? I mean, is there a ruler here somewhere that I'm missing? Tools. You'd think there would be. That would be a good feature, yes. Okay, so there's not, in other words. Okay, all right, fair enough. I mean, we know that it's 480 pixels. 640 pixels across. So if that's 600 pixels, I'm going to say the image is 40. So if you could sum up, you could spend 10K and generate your own picture of Jupiter. Oh, you could do it for a lot less than that, Wombat Hole. The camera we're using was $300. The telescope was about 800. There's 1100, and you need a mount. My mount is kind of a nice mount. It's a little more expensive, but you could buy yourself a really good used EQ6 for a little more than $1,000. Probably 2,500. Probably 2,500. If you want to get it, that's for a picture of Jupiter. If you want to get into deep sky and all that, that's a whole different conversation. But I think for 2,500, you could easily get yourself just as nice of a picture of Jupiter as this, if not nicer. Because I'm not using any guiding right now. I'm just it's just a camera, the telescope, and a mount essentially. You need a like a Raspberry Pi maybe to run it, So there's a few little extra bits and pieces, but essentially, you could even probably buy a used imaging rig from somebody for less than $2,500. You could also spend $10,000 and get slightly better pictures, But you could spend a 1.5 billion and build a space telescope and get even better pictures, but it doesn't have to be expensive. It doesn't have to be expensive. You can get good images of Jupiter with the Sea Star. Let me see if I can find one. They're not going to be incredible, but if we can find a good Sea Star image of Jupiter. Yeah, I mean, ought to do it. Welcome in. Good to see ya. Going down to 27F here in Central Florida. 27F in Florida? Bad seeing with the cold racing through, clear skies and good seeing to all. Take it easy. Good to see you, Astronomy Show. Have a good one. It's nice to see you again. I hope you're doing well. Yeah, here's some images taken with a... Oh, I didn't mean to click that one. I meant to click this one. Here's some images taken of Jupiter with the Sea Star. I mean, this is a relatively inexpensive. This is $500 or whatever. So you can do Jupiter with the Sea Star. There you go. You get Jupiter and its moons. Your clouds went away. Time to start imaging with the fossil footprint. Ooh, nice. Take it easy, Ninja Gloppy. Enjoy your imaging session. Yeah, so you can definitely do it for a lot less than 10 grand. How are we doing here? We seem to be... What does Auto Sharpen More do? I'm not really a fan of Auto Sharpen More. Okay, all right. So anyway, we come back to Jupiter on a clearer night, I'd say. I'm going to leave this in the background. We'll let it carry on doing its thing while we finish up talking about Jupiter itself. So we just looked at Jupiter live, and now we're going to talk about it again. Okay, so studies have disagreed about certain points, such as how much water and thus oxygen the planet contains. Yang saw an opportunity to apply a new generation of chemical modeling to the knotty question. The chemistry of Jupiter's atmosphere is incredibly complex. Molecules travel between the extremely hot conditions deep in the atmosphere and the cooler upper regions, changing phases and rearranging into different molecules via thousands of different types of reactions, but the behavior of clouds and droplets has to be accounted for. So we already kind of read that part, but to better capture all these phenomena, Yang worked with a team of scientists to incorporate both chemistry and hydrodynamics into one model, a first. You need both, Yang said. Chemistry is important, but doesn't include water droplets or cloud behavior. Hydrodynamics alone simplifies chemistry too much, so it's important to bring them together. Among the findings is a new calculation for how much oxygen Jupiter has. According to their analysis, Jupiter likely has about 1.5 times more than the Sun. It's storming here. I set my DJI up on the roof doing some ASMR streaming. Oh, cool, say Yogi One. Very nice. For decades, scientists had been arguing about this number because scientists love nothing more than a good argument. A major recent study had put it much lower at only 1/3 of the Sun's. But knowing this statistic is particularly relevant for understanding how our solar system formed. All of the elements that make up planets and us are the same stuff that makes up the Sun. But there can be differences in the amounts of these materials, and we can use those clues to piece together how the planets might have formed. For example, did Jupiter form in the same place where it is now, or did it form closer or further away and drift over time? Clues can come from the fact that much of the oxygen in the planet is bound up in water, which will freeze and behave differently if it's too far away from the warmth of the sun. Ice is easier for planets to accumulate than water vapor. In turn, knowing more about which conditions create which kinds of planets can help us as we search for habitable planets beyond our own solar system. Scientists are just lawyers who didn't want to give up their lab time. Yes, exactly. The model also suggests that Jupiter's atmosphere likely circulates up and down much more slowly than long believed. Our model suggests the diffusion would have been 35 to 40 times slower compared to what the standard assumption has been, said Yang. For example, it would take a single molecule several weeks to move through one layer of the atmosphere rather than hours. So this is sort of addressing that question that someone asked before, which is like, what's the relevance of the diffusion stuff? Well, it just means that the molecules are traveling much more slowly through the atmosphere than we previously thought. So all the transport processes are happening much more slowly. It really shows how much we still have to learn about planets, even in our own solar system, Yang said. And so here is, I'll give you this is the article on phys.org, which is a great site, by the way, if you want science news. I really like phys.org. And then the Planetary Science Journal is open access, thank goodness. So we can get some good stuff here. And then this is going to be a link to the paper itself. It's a fairly long paper, actually. Here, I'll show you the PDF. I forget how many pages. I want to say, 15. So, where's the model? There's a model here somewhere of the atmosphere. Is this the one? Oh, anyway, this is, here is this. No. Okay, yeah, so it's like 15 pages. It does get a bit complicated as well. I'm not gonna lie. It's probably not like might not be the best paper for someone who's not in the field to try and read. But if you're game and you want to learn some stuff, I mean, as always, all you got to do is read the paper and go when you get stuck, go down here to the references and start reading. But I mean, one paper could be. That's the thing I think people don't understand. To read one paper. You could read 15 papers, because like there's something comes up that you don't know and you're like, oh, okay. And then there's usually review papers, which are really good. So on a particular topic, someone at some point reads a bunch of papers and they're like, man, I need to write this down. And they make what's called a review paper. So they review a bunch of the state of the knowledge of a particular, area of astronomy or physics and so those review papers can be really handy to read because they can get you up to speed much more quickly than trying to read all of the papers because there's like seminal papers in all the fields, right? It's like, oh, this is the paper you have to read, and then you have to read this one, and then this one. That's fine, but that takes a very long time, and sometimes you just want to get through a paper and read it and kind of get a good understanding. And I think scientists want to prove wormholes are real just because they know how deep the rabbit hole goes. Yeah, the rabbit hole can be deep. I mean, look at this. There's what? I don't even know. There's probably 70 references here. And this is one paper. And then as soon as you go down to one of these other papers, guess what? More references. It's just reference soup at some point. It's easier if you just make it up. It is a lot easier, Captain Failure, to just make it up, but it's not as satisfying. Anyway, this is a really cool result, and I think it's super interesting. But maybe it's not as interesting. Like, I'm sure it doesn't get as many clicks as Hotels on Mars. Oh, and Hotels on the Moon, I mean, but I'll probably do that as a short tomorrow. Hotels on the Moon will probably be tomorrow's short. Okay, so that was the Jupiter paper. Close these down. Crew 11 we did. The moon thing we talked about. Yeah, I think we're actually ready. I think we're actually ready to switch gears. How long we got? What are we doing for time? 27 minutes left until ads. Okay, so I think what I'm going to do is we're probably going to end the stream over on YouTube. We did actually have a chatter in the YouTube stream. 2 chatters in the YouTube